Build My LED is a brand new company that manufactures commercial grade lighting systems that are built to your specifications. Previously, you only had two choices when it came to selecting a custom Spectrum LED lighting system. You could either build it yourself with LEDs and a soldering iron, or you could purchase a pre-configured product and settle for a very limited Spectrum offering. We believe our solution bridges the gap between mass customization and commercial grade LED lighting systems. Build My LED offers our customers the best of both worlds, and today we're going to show you how to use the LED Configurator on our website. Once you're at buildmyled.com, you have two choices. If you don't want to configure a custom Spectrum product, but you still want a high-power LED lighting system for your application, you can select pre-configured lighting systems for these 5 identified markets. Our team has a lot of experience in these markets, and we have configured many different LED lights for your project, so we take the guesswork out of building the Spectrum. To review the pre-configured lighting systems, start by clicking one of the markets listed here, and then click View All to review the available lighting products. If you want to customize your own Spectrum, start by clicking the Design It Yourself icon. Once you're at the configurator page, you can configure your personalized light by making 3 selections. In step 1, select the fixture length. We currently offer a 12-inch and 48-inch fixture, and we're planning to add a 24 and 36-inch option later this month. The 12-inch fixture uses 15 high-power LEDs, and the 48-inch fixture uses 60 high-power LEDs. You can get more details on the fixture construction in the downloadable spec sheet below. Once you've selected the fixture length, you get to configure your Spectrum in step 2. In this step, we give you the ability to configure over 155 million different color combinations. We provide a palette of 16 different color LEDs, and you place 15 LEDs in any order you choose. We will build your LEDs in this exact order. These LEDs will cover a 12-inch PCB, or printed circuit board, so we will assemble 4 of these boards end-to-end for a 48-inch fixture. There are 3 ways to select your LEDs. First, you can drag and drop the LEDs into the board. Just grab an LED and pull it into whatever slot you want. Second, you can double-click the LEDs and it will automatically fill the next available slot in the board. And third, as a shortcut, you can hold down Control, double-click an LED, and it will automatically fill the remaining open LED slots on the board. And as you drag and drop the LEDs, we provide real-time performance estimates, which are seen here on the right, and we provide real-time spectral charts, which are seen below the LED selections. We plan to create more videos later to dive deeper into these metrics, but I want to give you a quick overview of the metrics now. So on the right, we give you your fixture's estimated performance details. It's important to note these are fixture level metrics, so we've already taken into account the optical, thermal, and electrical losses of the total lighting system. So the first metric is estimated electrical watts. This is how many watts this system should pull off the wall plug on your wall. Next is the radiometric watts. This is how much light energy we've created with the lighting system. And one divided into the other gives you total wall plug efficiency, which is a key metric for any lighting system. Next section gives you lumens, lumens per watt, which is the system efficacy. Next is the CIE X and Y coordinate, and we're going to talk more about this when we look at the spectral graphs below, but these are very important numbers to understand the exact color of your lighting system. CCT is your correlated color temperature, which is the Kelvin scale that most of us use when we're talking about a lighting system. And then your CRI is a color rendering index, and this describes how the system is going to portray the colors underneath the light. PPF, which is photosynthetic photon flux, is described as micromoles per second, and we're going to get into that math later. PPF efficacy, which is how many PPF per watt. And then we give you a breakdown of the content in the blue, green, red, and far red range. Below the LED selections, you'll find 4 spectrum graphs. The first chart details the radiometric power of the integrated LED fixture. And this chart shows a breakdown of the radiometric flux listed in watts per nanometer of the spectrum. The next chart is the 1931 CIE color chromaticity diagram, and we place an X on the estimated XY coordinate location of your personalized fixture's color on this chart. Our forthcoming blog post will talk about various light color metrics, but in general, this XY coordinate system is a great way to compare various lighting systems. Many people today use CCT, or the Kelvin temperature of the light, but there are numerous shortcomings with only using the Kelvin temperature of a light source to describe its color properties. The next chart converts the radiometric spectrum to the photometric spectrum, which documents how the human eye will perceive the configured light source. As you configure the system, you'll notice how our vision is very sensitive to the green light region, but the sensitivity rapidly falls off in both the blue and the red regions. If you're creating a lighting system strictly for illumination purposes, this will be a very helpful chart for you. And note, if you compare the three charts of our custom reef spectrum, which we'll create now, many people think that this would be a very blue light if you just look at the first and last charts. However, once you look at the photometric spectrum, you will notice that the human eye does not perceive the large blue peak that's evident in the first and final chart. This is why the custom reef spectrum looks like a very balanced light on a saltwater tank. The final chart is a photosynthetic photon flux spectrum, which converts the radiant spectrum to a quantum or photon-based spectrum. According to the Stark-Einstein law, which is the second law of photochemistry, for each photon of light absorbed by a chemical system, only one molecule is activated for a subsequent reaction, regardless of the photon's energy. Hence, in photosynthetic applications, the total number of absorbable photons is the name of the game. For equal amounts of radiant power at 450 nanometers and 660 nanometers, the 660 nanometer red wavelength will have a higher photon count than the 450 nanometer blue wavelength. Since photon count is directly proportional to wavelength frequency, the 660 nanometer red wavelength will have 47% more photons than the blue wavelength in this example. To calculate the photon count of the spectrum, we use the following formula. To convert the radiometric watts per nanometer into photons per second, you divide by the photon's energy at each specific wavelength and integrate this over the specified active region. For photosynthetic active radiation, or PAR, the standard is to go over the visible range of light, which is 400 to 700 nanometers. Since plants are still photoreactive out to the near infrared, Build My LED integrates out to 750 nanometers. So the energy of a photon is described as Planck's constant times the frequency of light. And the frequency of light is the speed of light divided by the wavelength of light. Since the number of photons per second comes out to be a very large number, it is often divided by Avogadro's number, which describes the number of particles per mole. Hence, people often quantify photosynthetic lighting system in micromoles. Since there are 1 million micromoles per mole, the value above must be multiplied by 1 million. After all these unit conversions, you end up with micromoles of photons per second, which is the industry standard unit for measuring photosynthetic lighting systems. It may sound complicated, but the configurator instantly handles the math, and you can use this chart anytime you're designing a system that targets photosynthesis or photomorphogenesis. So after you've configured your spectrum, you can click on this button here to get a printable report of your fixture's estimated performance characteristics. This report also gives you the 4 charts we discussed earlier. As a side note, we're planning to add more LED color options in the near future, which will hopefully push the unique spectrum count to over 500 million combinations within the next 30 to 45 days. Once you're happy with your spectrum, you now select your beam angle in step 3. We offer narrow, medium, and wide optics, and these are 30, 60, and 90 degrees respectively. If you're using your light to direct an intense beam over a long distance, you'll probably want to use a narrow optic. If your LED light is close to the illuminated object and you want to ensure a large area is covered with a single fixture, you'll probably want to use the wider optic. For aquarium applications, remember to account for the change in the index of refraction as you're designing your lighting system. So going from an index of refraction of 1.0, which is air, to an index of 1.33, which is water, our 30, 60, and 90 degree beam angles will actually convert to 22, 44, and 64 degrees respectively. Hence, it's better to err on the wider beam angle selection for tanks that only use a single row of LED lights. Now that your fixture is designed, you can simply add it to your cart and select any options that you need, such as a dimmer and/or mounting kit. If you have any more questions about the LED configurator, feel free to contact us via email or phone. The Build My LED team is dedicated to bringing commercial-grade lighting products and more science to our customers, and we look forward to working with you on your next lighting design project.